Hi dear children, welcome back to our chemistry class. Today our new topic, laboratory preparation of hydrogen. How we can prepare hydrogen in laboratory. We can use dilute sulfuric acid or dilute hydrochloric acid on granulated zinc. Granulated zinc. By the action of dilute hydrochloric acid or dilute sulfuric acid on granulated zinc. Why we are using granulated zinc over pure zinc? Granulated zinc contains some impurities. For example, copper. Here, the copper acts as positive catalyst. Copper acts as positive catalyst. What is positive catalyst that we already studied? No. What is positive catalyst? Which increase the rate of the reaction. Positive catalyst increase the rate of the reaction. That's why granulated zinc is preferred over pure zinc. Okay, so how we can prepare? What are the reactants? Here dilute sulfuric acid or dilute hydrochloric acid, dilute sulfuric acid or dilute hydrochloric acid and granulated zinc. These are the reactants. Next we are going to discuss about the procedure of laboratory preparation of hydrogen. Dear children, procedure is that take few pieces of zinc granules taken in a round bottom flask. Okay, taken in a round bottom flask, and here we can see one airtight stopper is there. Through that, through here two hole is there. One hole, through that one hole we can fix one thistle funnel. This is thistle funnel and this is delivery tube. This delivery tube is connected with water. Okay, one end through that the round water flask and other end it is connected with the another container. That container is filled with water. Then we can pass dilute HCl or dilute H2SO4 through the thistle funnel. Okay, thistle funnel. At that time, what we can observe, small bubbles is formed. That is small bubbles is hydrogen. Okay, that is a liberation of hydrogen. നമ്മൾ dilute HCl or dilute sulfuric acid or നമ്മൾ ഈ thistle funnelൂടെ നമ്മൾ pass ചെയ്യുന്ന സമയത്ത് we can observe liberation of hydrogen. That means a small bubbles is formed. That is liberation of hydrogen. So we can collect that hydrogen gas in the water. We can see here one another container that is invertedly fix it. Okay, invertedly fix it. Why we are using that method is called downward displacement of water. Downward displacement of water because this container is filled with water. No. Because hydrogen is sparingly soluble in water. പകുതി മാത്രമാണ് hydrogen എന്ത് ചെയ്യുന്നത് വാട്ടറിൽ soluble ആകുന്നത്. So we can collect that hydrogen in a water. Why we are not using downward displacement of air? Because hydrogen is lighter than air. നമ്മുടെ ഹൈഡ്രജന് എയറിനേക്കാളും ലൈറ്റർ ആയതുകൊണ്ട് we can't collect that hydrogen in downward displacement of air. Is it clear? Downward displacement of air. We cannot collect the hydrogen in downward displacement of air because hydrogen is lighter than air. We can collect by using downward displacement of water because hydrogen is sparingly soluble in water. So we can collect hydrogen in downward displacement of water. That point is very important. Please underline in your textbook downward displacement of water. How hydrogen is collected? How is hydrogen collected? Hydrogen is collected by downward displacement of water. Hydrogen is collected by downward displacement of water. Why? Because hydrogen is sparingly soluble in water. Why we are not using downward displacement of air? Because hydrogen is lighter than air. Next, what are the precautions we need to take? First precaution is that do not collect first few bubbles of hydrogen. Do not collect first few bubbles of hydrogen. I told dilute hydrochloric acid is passed through that thistle funnel. It is contact with the zinc granules. At that time, liberation of hydrogen is there. That means the small bubbles of hydrogen is released. So do not collect first few bubbles of hydrogen because they contain air also. Okay, they contain air too. Second point, do not bring any flame of the apparatus. Do not bring any flame of the apparatus because hydrogen is highly inflammable gas. So do not bring any flame near the apparatus. These are the two precautions we need to take the preparation of hydrogen. First point, do not collect first few bubbles of hydrogen. Do not collect first few bubbles of hydrogen. What is the second point? Do not bring any flame near the apparatus. Why? Hydrogen is inflammable gas. Is it clear? Teacher, we can write the equation. Dilute HCl react with zinc. Dilute HCl react with zinc to produce which gas? Hydrogen gas. We know already we studied any metals, that is most reactive metals, react with acid or base, they release hydrogen. Most reactive metals, they react with acid or base, they release hydrogen gas. Similarly, we can write dilute HCl react with zinc, they produce which gas? Hydrogen gas, they release hydrogen gas. Here, zinc and chlorine combination, because zinc a hydrogen positive, chlorine negative, zinc positive ion. Okay, so zinc and chlorine combine with zinc chloride. Zinc chloride. Zinc valency plus 2. We should write under the subscript of chlorine. Chlorine valency 1. So here. So what is the equation? Zinc chloride is ZnCl2 plus H2. Then balance the equation. Hydrogen 2, here hydrogen 1. Chlorine peroxide 2. So multiplied by here 2. Okay. Similarly, next year. Dilute sulfuric acid H2SO4 is reacted with the granulated zinc to produce plus minus plus. So, which gas is released? Hydrogen gas. Hydrogen is a diatomic molecule. Then zinc joined with the sulfate to form zinc sulfate. Zinc sulfate. Zinc valency 2, sulfate valency also 2. Okay, zinc valency 2, sulfate valency 2. So the formula of zinc sulfate is ZnSO4. So here both sides hydrogen 2, peroxide also 2, sulfate here sulfur 1, peroxide 1, oxygen 4, peroxide oxygen 4, zinc left side zinc, peroxide zinc 1. So this equation is balanced, dear children. So what is the equation of balanced equation of dilute sulfuric action of dilute sulfuric acid on zinc? Dilute H2SO4 plus Zn gives ZnSO4 plus EH2. Clear now? Dear children, nitric acid also an acid. No. Why? We are not use dilute nitric acid in the laboratory preparation of hydrogen. Dilute nitric acid. Because dilute nitric acid is a strong oxidizing agent. It is a strong oxidizing agent. If we use dilute nitric acid, at that time, zinc nitrate and hydrogen gas is formed. Again, this I told nitric acid is a strong oxidizing agent. This strong oxidizing agent convert the hydrogen into water. Hydrogen A water I convert in. So dilute nitric acid is not used in the laboratory preparation of hydrogen. Clear now?